Hi everyone, my name is Neil Morrissey, and welcome to my course, Managing Microsoft Azure App Services. I'm a solutions architect and developer, and I'm excited to introduce you to Microsoft's Platform as a Service offering for hosting web applications, APIs, mobile backends, and small pieces of event-driven code called function apps. Whether you're an administrator or a developer, in this age of DevOps, it's important that everyone understands the environment that their applications are getting deployed to. And App Services is a highly available, robust environment with a lot of features to help you deliver and manage web-based applications. Some of the major topics we'll cover include a review of the different types of app services and the features that are unique about each of them, how to create and configure an app service, including deploying the app and setting up authentication, how to leverage deployment slots so you can deploy code to a staging area and verify it before swapping the code to production, and how to configure custom domains on your app service so you can have your own branded web address along with an SSL certificate to secure the endpoint. You'll see how to configure domain names and certificates you've purchased outside of Azure, as well as how you can purchase and manage domains and certificates right within the Azure portal. By the end of this course, you'll know how to set up and configure app services and how to deploy and secure an app with a custom domain and an SSL certificate. I hope you'll join me on this journey to learn managing Microsoft Azure App Services here on Pluralsight. Welcome to this course on managing Microsoft Azure App Service. In this module, you'll learn about the main features of app services and the app service plan that they run on, because the plan you choose defines what features are available to your app services. You'll see how to create an app service plan in the Azure portal. Then we'll talk about the most common types of apps you'll host in App Service. First, web apps for hosting websites and REST APIs, and then hosting custom containers on App Service. You'll see demos of both. Next, we'll discuss function apps, which allow you to host small pieces of code and integrate with various other services when you don't need a full-blown web app. You can host those outside of App Service too, but you have the ability to host them on an existing App Service plan if you're already paying for one. Then we'll talk about web jobs, which is another feature of Azure App Service that lets you host code that's more like a Windows service. So App Service isn't just for handling HTTP requests from users. And finally, we'll talk about a new feature that abstracts web application hosting even further. Static web apps are a feature of App Service that lets you deploy single-page applications that don't require server-side processing when you don't need the full power of App Service. They have global scale and integrate with Azure Functions. They're kind of an alternative to web apps on App Service because you don't have all the same features and configuration options, but they still fall under the umbrella of Azure App Services. So next, let's talk about the features of Azure App Services. Azure App Service is Microsoft's fully managed platform for hosting, deploying, and scaling web apps. You can host Windows or Linux apps built in a variety of languages. There's .NET and .NET Core, of course, but you can also deploy apps written in Java, PHP, Node.js, Python, and Ruby, and you can even host your own custom container images. Azure App Service is really just web servers that are hosted for you, so you don't have to worry about things like patching them or managing the underlying operating system. You still get a lot of control over configuring features of the environment though, and you'll see that throughout this course. You host your app services on an app service plan, which is a separate resource in Azure that needs to be created. This defines the size of the servers your apps run on and the geographic region where the servers are deployed. You can host multiple app services on a single app service plan. You'll learn more about app service plans in the next clip. App Service has a lot of features and benefits for administrators and developers. I know those roles are blurred with DevOps, but let's talk first about some of the hosting features. When you deploy your app onto App Service, you can scale out the environment to handle increased or decreased load. If you expect a period where more users will be coming to your site, you can add more instances or servers to handle the load and remove those servers later, so you don't end up paying for a lot of extra infrastructure that you don't need. And you can even automate that scaling using a feature called Autoscale, where you add and remove servers based on a schedule or based on metrics you define, like how much memory or CPU is being used by the servers. You can also scale up and down, meaning that you can change the amount of CPU power, memory, and disk space of the underlying virtual machines your apps are running on. So there's a lot of flexibility to control the size and power of the environment. I won't cover scaling in this course, but I have another course that covers it in detail, called Managing Microsoft Azure App Service Plan. When you're running multiple web servers in your App Service plan, you get built-in load balancing. If you migrate an application to App Services that stores user state on the web server, you can have session affinity, so users are directed back to the same server. You'll see the various configuration settings in the next module. For more advanced app publishing and to load balance across Azure regions, you can integrate App Service with other Azure services like Traffic Manager and Azure Front Door. You can manage app configuration values outside of the application code, and that's a feature that allows you to configure deployment slots for your app, which are separate instances of the app for development, testing, and production. You can swap the deployment slots to move your app code through those environments, right from within App Service, without having to redeploy. There's a whole module on deployment slots later in this course. You can back up and restore your app and configuration information to an Azure storage account, either manually or on a schedule, and you can even include databases that the app uses. When it comes to monitoring and troubleshooting your app service, there are built-in diagnostics logs for the web server as well as for the application, and you can easily integrate with a service called Application Insights for a deep view into your application's usage and performance. There are metrics available to view the ongoing health of the app service, and you can create alerts when thresholds are reached. Visual Studio developers can even leverage live site debugging of the running app in Azure App Service. Monitoring and diagnostics is covered in the App Service Plan course also. There's also a set of management and deployment tools for each app service, and they're offered through a portal called Kudu. When you create a web app, it gets a default URL with the name of your app service and azurewebsites.net. If you insert SCM between your site name and azurewebsites.net, you can get to the Kudu portal for your app service. You can deploy the app from here using a zip file. You can interact with the files on the file system, view the processes running on your site, and even view the environment variables, so you can really see what's happening within the runtime environment that you're deploying to. You can run commands in PowerShell from the debug menu, and view log files and download diagnostic dumps. When you're having issues with your site, Kudu can really help with diagnosis. I mentioned that your app gets a default domain at azurewebsites.net, but you can add your own custom domain, and you can attach an SSL certificate to those domains. You'll see both those features in detail later in this course. App Service Plan also includes a lot of security and networking features, like being able to restrict who can access the app using IP restrictions. If your app service is on the premium pricing tier, you also get the ability to restrict access to the app service from only your own virtual network using a private endpoint. That makes your app service inaccessible from the public internet. If you've connected your on-premises networks to your VNet using a VPN or ExpressRoute, the app services would be available through there also. And even though your app is hosted in a Platform as a Service public environment, you can enable access to resources in your Azure virtual networks, or even allow your apps to connect to on-premises databases and applications. You can also leverage built-in authentication features for users of your applications, so you don't have to build that part yourself. You can set up an app service so users have to authenticate to Azure Active Directory before they reach your application, and App Service will then pass the user information along to your app, so your code can use it to make authorization decisions. You can also have them authenticate through services like Google, Facebook, Twitter, or using Microsoft accounts like Hotmail and Outlook identities. The authentication happens before requests reach your app, so it works for apps written in any framework and language. In the next module, we'll deploy a web app and set up Azure Active Directory authentication for users to authenticate. You can also configure an app service as a service principal in Azure Active Directory, so the app itself can authenticate to other services, like Azure SQL Database. App Service integrates with your continuous integration and continuous deployment tools also, so there's deep integration with Azure DevOps and GitHub, as well as other services. There are a variety of deployment options besides CI/CD, and we'll review those in the next module. So next, let's talk about the underlying App Service Plan that hosts your app services. An Azure App Service Plan is the container that defines a set of compute resources for your app services to use. You can think of it like a server farm. An App Service Plan can host multiple app services, so all the web apps, containers, REST APIs, and function apps you create within an App Service Plan run on all the virtual machines in the plan. So do any web jobs you configure. An App Service Plan defines the region that the VMs run in, the number of VM instances, which is the number of VMs it's possible to scale out to, the size of the VM instances, and the pricing tier. The pricing tier determines the limits in terms of things like disk space for your app services, the number of apps you can host, and the number of VM instances you can scale out to within the plan. But the pricing tier also determines what features are available. You can see the features available on the different plans by navigating to azure.microsoft.com/pricing/details/app service. For example, you can deploy an app service onto the free tier to start. But when you want to use a custom domain for your web app, you need to scale up your app service plan to the shared tier, at least. The free and shared tiers use shared infrastructure, meaning your apps run on the same VMs as other customers. This is fine for development and testing though, as long as you don't need to use any of the features of the other tiers. The basic, standard, and premium tiers run your apps on VMs that are dedicated to you. The higher the tier, the more features and the more VM instances you can scale out to, either manually or through auto-scaling. The isolated tier runs your VMs on a dedicated Azure virtual network, so you get network isolation in addition to the compute isolation of the dedicated tiers. The isolated tier is also known as App Service Environment, or ASE. You can run Windows and Linux web apps and APIs, Docker containers, and function apps in ASE. You get true network isolation in that your app service environment is deployed in your own virtual network, so you have fine-grained control over inbound and outbound network traffic. You can see the full set of features for the different plans by clicking on this link. If you want to secure your custom domain with an SSL certificate, you need to at least be on the basic pricing tier. And if you want to use deployment slots, also called staging slots, you need to be on the standard pricing tier. Since those are all the features that we'll be using in this course, I'll be doing the demos in an app service plan created with the standard pricing tier. Now let's see how we can create an app service plan in the Azure portal. After that, we'll create a web app that runs on the app service plan. Now let's create an app service plan in Azure so we can use it to host app services. I'll navigate to portal.azure.com and I'll log in using the credentials of a Microsoft account that I used to set up the Azure subscription. It's a good idea to use accounts stored in your Azure Active Directory tenant for administration though. The password is cached in the browser, which again, isn't great security practice, but I do have multi-factor authentication set up for this account, so I'll bring up my phone where I've gotten a push notification from Azure MFA. All I need to do is click Approve in the Microsoft Authenticator app, and also scan my fingerprint on the device. Now I'm logged into the Azure portal using Azure MFA. If you want to know more about setting up multi-factor authentication for administrators and for your application users, I've got an entire course in the Pluralsight library called Implementing and Managing Microsoft Azure Multi-Factor Authentication. You can create an app service plan during the creation of your first app service, but let's create the app service plan first, and then add an app service to it. Let's go to Create a Resource and search for App Service Plan. I'll click on the pop-up, and on the Overview page, click Create. The first thing we need to do is specify a resource group. All resources in Azure created using the Azure Resource Manager model need to store their metadata in a resource group. We could choose an existing resource group from the subscription, but I'll create a new one, so it's easy to delete all the resources later. I'll just give it a name, and by default it will get created in the same region that we choose to create the app service plan in. But if you choose an existing resource group, it can actually be in a different region than the app service plan. The resource group just stores metadata. Now let's give the app service plan a name, and this just needs to be unique within your subscription. Next, we choose an operating system. You can host apps on Windows virtual machines or on Linux, which actually runs your apps on Docker containers. But you can't mix Windows and Linux apps in the same app service plan, so you choose at the app service plan level. You can also run custom Docker containers as app services on either platform, and you'll see that when we create an app service. Let's choose Windows and select the region we want to deploy the infrastructure to. It's good to choose a region that's close to the users of the applications. If you have users in other parts of the world, you can either create multiple app service plans and load balance them with Azure Traffic Manager, or you can leverage the Azure Content Delivery Network. I'll choose the region closest to me, and now we choose the pricing tier. This defines the size of the virtual machines, as well as the features that will be available to the app services we host. Let's click here to see what's available. The screen defaults to the production pricing tiers, but let's switch to the Dev Test tab. The free tier is pretty limited in terms of features, so let's look at the shared tier. If we choose this tier, we can use custom domains for our app services. Remember in the previous clip, we saw this in a chart form. On the basic tier, we can also use SSL certificates with those custom domains, and we can manually scale our app service plan up to 3 virtual machines to handle more load. Switching to the production tab, we get more features with each of these pricing tiers, and the cost increases also. The standard tier gives us staging slots, also called deployment slots, which we'll look at later. Moving to the premium tier, we have the same features here, but we're running on more powerful virtual machines, and some of the quotas are higher for things like staging slots and hybrid connections. Let's choose the standard tier, because that'll give us the features we need for the rest of the modules in this course. Next, we can create tags, which are useful for billing and automation purposes, but we can do that later. Let's go ahead and create this app service plan. It'll take a few seconds to create, so I've paused the recording. And once it's created, we could navigate to the app service plan from here. But let's go to a shortcut I have for all the app service plans in this subscription. You can see I have a number of plans created. I've actually created many of these before using the standard pricing tier, and then scaled them down to the free tier to save costs. I'll show you how to do that in a second. Let's click on the one we just created. And on the overview page, there's some charts with metrics. Of course, there are no apps in this plan yet that would cause traffic, so it's empty. We can see there's no app services from the apps menu. What's interesting is that you can't create app services from here. You choose the app service plan when you create an app service, as you'll see later in this module. This page just shows the ones running on the app service plan. You can see how much storage is being used on this plan. When you upload code, storage is used. It's actually stored outside the virtual machine on a shared drive in Azure Storage. But there is a quota on the total storage for those files, and it depends on the pricing tier you choose for your app service plan. For this standard plan, it's 50 gigabytes total for all the app services. On the premium pricing tiers, that goes up to 250 gigabytes. The Scale Up menu is where you can change the pricing tier. You can start small, and if you find your app services are using a lot of resources, you could scale up the size of the underlying virtual machines. And if you think you don't need the resources you have allocated, you can also scale down. But you need to make sure all the features you're using are supported in the lower pricing tier. The Scale Out menu is where you can add more instances, or VMs. If you have a lot of traffic going to your website, you may want to increase the number of VMs handling the traffic. If you're on the standard pricing tier or higher, you can also configure auto-scaling. You can auto-scale based on rules that you configure here. Let's close this for now and go down the menu. There's more options for monitoring and logging the performance of your app service plan, and higher up, there are options for networking. VNet integration allows your app services to access resources created in your Azure virtual networks, like infrastructure as a service VMs and databases, and hybrid connections can be used to access resources on premises. On the menu for individual app services, there are more networking features available also. So that's an overview of the app service plan that's going to host our app services. The app service plan has been created, and we could navigate to it from here. But let's go to a shortcut I have for all the app service plans in this subscription. You can see I have a number of plans created. I've actually created many of these before using the standard pricing tier, and then scaled them down to the free tier to save costs. I'll show you how to do that in a second. Let's click on the one we just created. And on the overview page, there's some charts with metrics. Of course, there are no apps in this plan yet that would cause traffic, so it's empty. We can see there's no app services from the apps menu. What's interesting is that you can't create app services from here. You choose the app service plan when you create an app service, as you'll see later in this module. This page just shows the ones running on the app service plan. You can see how much storage is being used on this plan. When you upload code, storage is used. It's actually stored outside the virtual machine on a shared drive in Azure Storage. But there is a quota on the total storage for those files, and it depends on the pricing tier you choose for your app service plan. For this standard plan, it's 50 gigabytes total for all the app services. On the premium pricing tiers, that goes up to 250 gigabytes. The Scale Up menu is where you can change the pricing tier. You can start small, and if you find your app services are using a lot of resources, you could scale up the size of the underlying virtual machines. And if you think you don't need the resources you have allocated, you can also scale down. But you need to make sure all the features you're using are supported in the lower pricing tier. The Scale Out menu is where you can add more instances, or VMs. If you have a lot of traffic going to your website, you may want to increase the number of VMs handling the traffic. If you're on the standard pricing tier or higher, you can also configure auto-scaling. You can auto-scale based on rules that you configure here. Let's close this for now and go down the menu. There's more options for monitoring and logging the performance of your app service plan, and higher up, there are options for networking. VNet integration allows your app services to access resources created in your Azure virtual networks, like infrastructure as a service VMs and databases, and hybrid connections can be used to access resources on premises. On the menu for individual app services, there are more networking features available also. So that's an overview of the app service plan that's going to host our app services. Now let's talk about the main type of application you'll typically host on an Azure App Service, and that's web apps. Azure App Service has its origins in a service called Azure Websites. When you create a new app in App Service, it gets a default URL with the name you provide, suffixed with azurewebsites.net. Until recently, there were three types of app services you could create: web apps, API apps, and mobile apps. They were essentially the same though, since they were hosted on the same infrastructure that had the same features available, like scaling, authentication, and configuration. But now it's just web apps, and you can host REST APIs on web apps, and you can use REST APIs as mobile backends. So most of the same functionality is still available, although a few features of mobile apps have been deprecated, and I'll talk about that in a bit. You can deploy code to web apps or deploy custom container images from a container registry. We'll talk more about containers later in this module. When deploying code, you can deploy to a variety of frameworks on either Windows virtual machines or to built-in Linux containers. Some frameworks will work on both operating systems, and some are specific to one type of OS. I'll show you that in the demo in this clip. There are some specific features of an app service that apply to hosting REST APIs. Anytime you're consuming an API from a browser, you have to consider cross-origin resource sharing. Security restrictions in web browsers prevent them from making requests to servers in a different domain than the one the web page is in. It's also known as same origin policy. Cross-origin resource sharing is a W3C standard that lets servers send a header response to the browser that indicates what domains the server will allow requests from. You can configure that list of allowed origin domains from within the app service. There are often situations where you're composing an enterprise application for microservices deployed as REST APIs, and you can end up with a lot of APIs distributed throughout your organization. It can be challenging for developers to understand the various methods that can be called. So there's an open standard called OpenAPI, also called Swagger, and that lets you generate interactive documentation and help pages for REST APIs. This helps with providing interactive documentation, API discoverability, and with generating client proxy code. It's basically a document you generate in your app called swagger.json that you can make available as an endpoint in your app. Then it becomes easy to integrate your REST API with a logic app workflow, with Power Apps, or generate a client proxy in Visual Studio. So you can use REST APIs as microservices to compose enterprise applications from loosely connected services. But when you start to get a lot of APIs, it becomes a challenge to manage them. For that, you can leverage Azure API Management. Azure API Management lets you put a front end on your APIs to monitor and throttle usage, to manipulate input and output, and consolidate several APIs into one. It also provides a portal for developers and external clients, and can augment the security and monitoring of your REST APIs. Although Azure API Management is a separate service in Azure and isn't part of Azure App Service, I just wanted to mention it in this section on REST APIs because it can be used in conjunction with app services. The ability to host REST APIs in an app service means that you can create the backends for a mobile application. But there used to be something called App Service Mobile Apps, and there were a few additional features for hosting APIs and simple table data, and those were called Easy Tables and Easy APIs. But these were removed from Azure App Service in 2019. There's now another service in Azure called App Center, which provides tools to build, test, and monitor mobile applications. Next, let's create a web app in the Azure portal and see some of the options available. Now let's create a web app on the app service plan we created earlier. I'll go to Create a Resource on the menu, and I could search for web app, but it's already here in the popular list, so I'll click on that, and it brings us right to the creation screen. The first thing we do is choose a resource group. We could create one also from here, and your web app doesn't need to be in the same resource group as the app service plan, by the way. But let's keep everything in the resource group that we created with the app service plan. Now we enter a name for the web app. This will be used to create the default URL for the app, which is suffixed with azurewebsites.net, so it needs to be unique across Azure. Next, we have to indicate if we're going to be deploying code or a custom Docker container. If we leave code, we need to select a runtime stack, and this will allow us to select an operating system, because not all runtimes are available on both operating systems. In the list here, we've got ASP.NET for Windows, including .NET 5, .NET Core, Java, Node, PHP, Python, and Ruby. If I select ASP.NET, only the Windows operating system is available, and we'll have to deploy this onto an app service plan that was created for Windows, not Linux. If I select .NET Core, because it's cross-platform compatible, this web app can be deployed onto Linux or Windows. If I select Node, it's the same thing. But if I select Ruby, for example, only Linux is available for that runtime. And by the way, when you select Linux, it's not running on native Linux VMs. This is actually an abstraction, where the framework is hosted on Linux containers. So let's choose .NET Core. And next we choose the region we want it deployed to. But before I do that, let's look at the app service plan at the bottom. We haven't selected one yet, and the plans available in this list are dependent on the region that you select above. So I don't have an app service plan already created in the Central US region selected above, so there's no existing app service plan in the list. But I could actually create a new app service plan during the creation of this web app, and I can select the plan size here also. But let's select the region where I created the app service plan. And when I do that, the list refreshes, and I can select the existing app service plan. Now, before we move on to the monitoring tab, let me just show you what happens when you select Docker container instead of a code deployment. The runtime stack selection disappears, and a tab gets added in this wizard where you can choose a container from a container registry. I'll show you more on this later. So let's change back to a code deployment, and let's move to the next tab. On this tab, you can choose to create an Application Insights instance for this web app. App Insights gives you deep monitoring into the health and usage of your application. It's beyond the scope of this course though. So let's turn this off and move on to the next tab. You can add tags to this app service, just like the app service plan. You might want to add the project name or the business unit this app belongs to, but we can also do that later. So let's review our selections. And now let's create this web app. It'll take a few seconds, so I'll speed things up a bit. Now the web app is created, so let's navigate to it. It says the status is running, and we'll look at the default page that gets deployed in a second, but let's just quickly look at the menu on the left. There's a deployment section, and that's where we create deployment slots, which you'll see later in the course. There's a configuration section, and we'll look at this in the next module. We can navigate to the underlying app service plan from here. There are development tools, like access to the Kudu portal from here. There's some tools for managing APIs hosted on the web app that I mentioned in the previous clip. And there are tools for monitoring and logging. So let's go back to the top here, and we could copy this URL into another browser tab to see the default page that gets deployed. Or we can just click on this Browse button. That opens up another tab where we can see that the web app is up and running. In the next module, we'll be deploying our own code to this web app instance. Now let's talk about hosting custom containers on Azure App Service. Containers are a way to wrap up an application into its own isolated package. When an app is deployed using a container, everything the application needs to run successfully is included in the container, like runtimes and library dependencies. This makes it easy to move the container around from your local workstation to VMs in your on-premises environment that have a container runtime installed, or to a managed container hosting service in Azure. Azure App Service allows you to deploy container instances onto an app service plan as an app service. You can upload your images to a container registry, and you can pull those images from the registry. You can use Docker Hub, Azure Container Registry, or any private registry available on the internet. When you run a custom Docker image in App Service pulls the image layers and stores them on disk. You can host Linux or Windows containers on App Service. So why would you want to deploy your app to a container instead of just deploying the code? There's a few good reasons. Azure App Service supports code deployments on a variety of application stacks, but if the one you want isn't available, you can just install all the dependencies and frameworks you need onto a custom container and deploy that. Because containers virtualize the operating system, using a container can help overcome some of the limitations of running code natively on the app service plan. For example, when you deploy code, you have limited access to the underlying operating system of the VMs in the app service plan. If you have a library that generates PDFs, for example, you can't access the underlying Windows Graphical Device Interface APIs. If you deploy your app on Windows containers to App Service, these calls will succeed. Things like custom fonts are another example, or apps that use COM+, or rely on assemblies deployed to the global assembly cache. So if you're moving a legacy application to the cloud, containers give you an opportunity to lift and shift the app without re-architecting it for the cloud. Containers on Azure App Service also provide CI/CD capabilities for DevOps with Docker Hub, Azure Container Registry, and Azure DevOps, and they share many of the other features of App Service. Hosting Linux containers has been available for some time in App Service, and there's now the ability to host multi-container Docker applications using Docker Compose. That functionality is currently in preview, and it's beyond the scope of this course, but it shows how App Service is maturing beyond being a service for hosting single container instances. Windows containers are now also available, and as I mentioned above, one of the great features is that it lets your application have more access to the underlying operating system capabilities than just running native code in an app service. App Service isn't the only way to host containers in Azure, by the way. There are several other services available, some specifically for containers. Azure Container Instances, or ACI, is intended for smaller applications like simple web apps, or dev test scenarios, and small-scale batch processing. With ACI, you can only have a single container instance per container image, so you won't get high availability and you have limited scalability. But one of the great things about ACI is that you're only billed for the time that you use the container. With App Service, you pay for the underlying App Service plan, regardless of whether or not the container is doing any work or servicing any requests. So ACI is good for short-lived containers. You can run containers in the Azure Batch service to scale large numbers of batch computing jobs like image processing or financial risk simulation. For more complex architectures involving containers, like microservices for example, you probably want more control around deploying and managing the health and performance of containers that make up your application. For these requirements, you can move to a container orchestration service. Azure Kubernetes Service, or AKS, is Microsoft's managed hosting of Kubernetes, which is an open source project. Azure Service Fabric is another option for container orchestration to run containerized stateful services. Next, let's create a web app for containers. Now let's create a web app that hosts a custom container. You can do this from the web app creation screen, but there's another option called Web App for Containers. Let's go this route so I can show you the difference. Let's click Create, and we get brought to a similar screen as before. The only difference is that Docker Container is already selected, and it appears that Linux is only available. This is just because when containers were first introduced to App Service, you could only deploy Linux containers. If you click the Code button and then change back to Docker Container, now the Windows option is available. I've got another tab open where I'm in the process of creating a plain old web app. And if I choose Docker Container, you can see that I'm at the same point in the process. So you can get to the same place just by creating a plain old web app. Let's go back to the other tab though and continue the process. I'll put this in a new resource group. And I'll give this app service a name. We'll leave Docker Container, and notice there's no selection for the runtime. The runtime will be whatever is on your custom Docker container. Let's leave Linux and choose the Canada Central region. Now I don't have any existing Linux app service plans in this region. The app service plan we created was for Windows. So my only option is to create a new one, but we can choose the pricing tier for the app service plan right from here. You can see there are premium plans available, and also free and basic plans for hosting Linux containers. Now let's close this and change to Windows. I actually have an app service plan I can use, and it's not the same one we created earlier. I actually created this one in the process of creating a Windows container. So it appears, at least at the time of filming, there is a restriction on hosting Windows apps and Windows containers on the same app service plan. But let's create a new plan so we can see the options. Now when I choose a pricing tier, there are only these premium V3 tiers available. Hosting Windows containers is fairly new, and at the time of filming, it's only supported on these pricing tiers. There are no free or basic plans available for Windows containers. And remember how we created a Windows app service plan in the Canada Central region for our web app? Well, because I chose the Docker option, that plan actually isn't available for me to deploy the container to. For Windows containers, you need to create the app service plan in the process of creating a Windows container app service. But once the app service plan is created, you can use it to host other Windows containers. That seems to be a limitation of the Windows plan, but not the Linux plans. With Linux, you can select an existing Linux app service plan for either web apps or Docker containers. Let's change back to Linux. And let's give our new app service plan a better name. I'll leave the default size, and let's move on to the Docker tab. The first thing we choose is whether we're hosting a single container or using a Docker Compose file for multiple containers. That's currently in preview at the time of filming. Let's leave single container, and now we choose the source for our image. There's a quick start image that we'll actually use here in a second, but let's look at the other options first. Docker Hub is a popular source for images, and you can upload your own to a public or private registry. You can also use Azure Container Registry. Now I don't have any registries created in this subscription, but if I did, I could select an existing image from here. And you can also pull the image from a private container registry, which could be an external service or something that you host yourself. So there's a lot of flexibility here. But let's select the Quick Start image, just so we can get something up and running. On the Monitoring tab, this is where we turned off the creation of an Application Insights instance when we created a web app. We actually don't have this option for containers. It's off by default. Let's skip Tags and go to the Create screen. It'll take a little time to create this. Remember, it's also creating an app service plan at the same time. So I'll speed things up a little bit here. And once the plan and app service are created, let's navigate to the app service. You'll notice we've got most of the same menu items available here. But there's a new item for container settings. This is where you can change the image source for this container. So you have control over this after the app service is created. And you can enable continuous deployment from here too, and add a webhook URL to facilitate that. Let's discard these changes and go back to the overview screen. We'll browse to the newly created container, and we get a page on the default URL that's being served up by the quick start image we deployed to this app service. Okay, next let's talk about a few more types of apps that you can host on Azure App Service. Azure Functions let you run small pieces of code, or functions, so you don't need to host a whole application. Sometimes you just need to respond to an event and process some data, and you don't want to create the scaffolding for a full application to do it. Azure Functions provides an event-driven model to respond to direct calls to the function, or by listening for events from various services inside and outside of Azure. A function can be triggered by an HTTP request, a timer running on a schedule you define, and events, like from a storage account, where a blob is getting added or a message is being pushed into a queue. Your function could be triggered when documents are added or modified in a Cosmos DB database, or by listening for events from Azure Event Hubs and Event Grid. You could also have your function respond to a webhook, like an update in GitHub. Azure Functions let you stitch together a simple workflow, like picking up a file deposited in Azure Blob Storage, parsing it, and adding the data to a SQL database. You can write functions in C#, Java, JavaScript, PowerShell, or Python, or you can use a custom handler to use virtually any other language. Azure Functions are considered serverless compute because, similar to logic apps, you can opt for a consumption-based plan whereby you only pay for the execution time of the function and the resources used. Basically, you only pay when the functions are run. But if you're already paying for an Azure App Service plan, you can also deploy your function apps on the same infrastructure, and you won't incur any additional costs. If your functions are running a lot, it could be more cost-effective to use the App Service plan too, rather than using the consumption-based model. When hosting your function apps on Azure App Service, you get control over all the built-in app service features, like network integration, auto-scaling, authentication, continuous integration, deployment slots, custom domains, and SSL certificates. There's also another offering for hosting function apps, in addition to the consumption-based plan and Azure App Service. The Azure Functions Premium plan keeps an instance of your function app available to avoid cold starts, and allows for elastic scalability based on the number of incoming events. It's not billed per execution, like the consumption plan, but it's billed based on the number of cores and the memory allocated. Next, let's talk about another way to run code on your app service instances, called web jobs. Web jobs aren't really a type of app service. They run alongside an existing app service you create. In other words, they run on a web app. They're a feature of Azure App Service that lets you run a program or script in the same context as your web app. You can't deploy a web job onto a web app hosting a container, but of course you could run similar tasks right within the container itself. Web jobs also aren't available on app service plans created for Linux apps. You can run apps and scripts you would typically run from a Windows command prompt, like an exe, bat, or command file. And you can run a PowerShell script, an sh script using bash, a PHP file, a Python script, or a Node.js script, or even a Java application. You zip up all the files you need to run your web job and upload them to your app service. Once you have an app service created, under the Settings menu, you can click on Web Jobs. And here you can upload a zip file containing your executable or script files and any supporting files. Then the web job is configured to either run continuously or only when you trigger it. You can specify a schedule to run your web job, or run it by calling a webhook. There's no additional cost to use web jobs. They just run within the context of the existing web app. You can think of web jobs kind of like Windows services running on a VM, but keep in mind that you're still running in a platform as a service environment. Even though your app services are running on virtual machines and have access to some of the underlying features, there are restrictions to what you can do. You can't write to the registry, for example. You can't access the actual Windows event log, and you can't leverage shared components of Windows, like the cryptography and graphics subsystems. But remember that running a Windows container on App Service can provide greater access to the operating system functionality. Next, let's talk about a new feature of App Service for hosting static web apps like single-page applications. The last type of app I want to talk about is called a static web app. Static web apps are usually built using libraries and frameworks like Angular, React, Vue, or Blazor. These apps are made up of HTML pages, CSS, and JavaScript files, and image assets. The front-end applications run in the browser, so they're separate from any back-end processing, but they'll still usually call out to REST APIs to send and retrieve data. With a traditional web server, the static web app is served from a single server alongside any required API endpoints. But it's possible to host the static content in a couple of other ways. You can actually serve static files right from an Azure storage account by hosting the files in the blob service. You get a public URL, like a web server, but there isn't much functionality beyond that. There's a new feature in App Service called Static Web Apps that automatically builds and deploys full-stack web apps to Azure from a GitHub repository. So it integrates directly with GitHub Actions for continuous integration and deployment. When the GitHub action deploys your code to static web apps, you get automatically deployed to at least 5 web servers and regions around the world, so you get automatic global scaling. It also allows for deploying any server-side code as Azure Functions, so you can develop your front-end code and functions within your Visual Studio or Visual Studio Code projects, and then deploy the projects into GitHub and get built-in deployment. Static web apps support custom domains, and a pull request to GitHub automatically generates a staging site for testing your app before deploying it to production. Even though static web apps fall under the umbrella of app services, they aren't deployed to an app service plan. Static web app is really its own hosting service. That said, you do get some additional features for routing and authorization, so it's like a scaled-down version of app service, with just the features you need for these types of apps. Let's take a look in the portal next. Let's go to Create a Resource and search for Static Web Apps. And let's look at the creation screen. Here we've got the usual stuff, the resource group and the name of the app, but notice it isn't suffixed with azurewebsites.net. There will actually be a random URL created, but you can add a custom domain later. You choose the region for deployment, but it will actually get deployed to 5 regions around the world by Azure. You do need to link to your GitHub account for the code deployment, so I'll sign into mine. I just need to authorize the Static Web Apps service from my GitHub account and log in. This is standard OAuth 2.0 authorization stuff. Now we can choose my GitHub organization and select a repository to publish the code from, and select the branch. Next, we can select build presets for different front-end frameworks and static site generators. These are the ones currently supported. If you just have a basic HTML site like I'm going to show you, you can choose custom. Then it asks you to choose the API location. This is only needed if you plan to create function apps for the back end of your site. I've actually created a couple of these static web apps already though, so let's exit out of here and go to All Services, Static Web Apps. Before I show you the app, let's take a look at the source code in VS Code. I had to install this extension for static web apps. This is just a basic HTML site with an Azure function. The index.html page calls the function, whose path is under the API folder. So even though the function app will get deployed as an Azure function, it gets resolved in your code as if it's a subfolder of your app. I have an Azure function here. It's just an HTTP trigger, and it's written using Node.js. But you can also use .NET Core 3.1 or Python. The function just returns some text. I've already pushed this to my GitHub repo that I linked to my static web app, and done a push, which builds and deploys the app using GitHub Actions. We'll talk a bit about GitHub Actions and other deployment methods for app services in the next module. Now let's go to the Azure portal and take a look at the deployed app. Just like with regular web apps, we can browse to the deployed site from the overview page. You can see it opens a tab with a URL that was randomly generated by Azure, and it's suffixed with azurestaticapps.net. It actually took a second for the text to be retrieved from the function app, but this is the basic site, and I just cloned this from a repo in a Microsoft tutorial. Now let's look at some of the settings in the portal. I know we haven't gone into detail on configuration with standard web apps yet, but you can probably see already that the menu items are different here. We can configure application settings that are used by the different deployment slots in the app. We can configure a custom domain, and there are a list of functions that have been deployed. Notice you can't do anything more than just see the list here. If we created a pull request in GitHub, a deployment slot would get created where we could test our app on a different URL before we deploy it to production. And role management is very interesting here. This is a really simple way of controlling access to your application. You can invite users, and they can authenticate using different services like Azure AD, GitHub, Facebook, Twitter, and Google. You assign them roles, which are just strings, and I'll show you in a second how these are used. And then you generate a link that you need to email to them. I have a user that's already accepted the invitation and authorized access from their Twitter account, so I can change the roles afterwards. Now, in the code, you create a file called routes.json, and this is where you can specify the different paths that different roles are allowed to access or are restricted from accessing. Static web apps are currently in preview, so I'm sure functionality will be getting added, but they provide a powerful way to deploy single-page applications and static files while leveraging Azure Functions on the back end. In this module, you got an overview of Azure App Services and the app service plans that they're hosted on. You learned about web apps and saw how to create a standard web app as well as a web app hosted on a container. You learned about some of the other types of apps that can be hosted on an app service plan, like function apps and web jobs. And you saw a new kind of app service called static web apps. In the next module, we'll dive into the configuration of app services, and you'll learn about deployment and authentication options. In the previous module, you learned about the different types of applications that can be hosted in Azure App Service and how to create them in the Azure portal. In this module, we're going to dive into some of the configuration options for web apps and then for containers that are deployed onto an app service. Then you'll learn about the different options for deploying your app into App Service. After that, we're going to create a new ASP.NET Core web application in Visual Studio, publish the files to a folder and zip them up, then deploy them onto an app service using the administrative Kudu portal. And finally, you'll see how to use the built-in authentication capabilities of App Service to require a user to authenticate with Azure Active Directory before getting access to the deployed application. Let's get started by looking at configuration settings next. Let's look at the configuration options for web apps. This is the web app we created in the previous module. It was created on a Windows App Service plan and the standard pricing tier. Let's go down to the configuration menu under the settings group. The first tab is for application settings. This is where you can set app settings as environment variables to the code in your application. This is also where you can override connection strings. For ASP.NET developers, both of these types of name-value pairs override any settings specified in web.config or appsettings.json, so you can have your local settings when developing, like a password to a local database, for example. And then when the app is deployed, those settings can be overridden here. These are just strings, and you can create whatever name-value pairs you want to be used by your code. There are also a lot of predefined names that you'll see throughout the documentation that enable switches and functionality in App Service. When you create your own setting, notice the checkbox for deployment slot settings. You'll learn more about this in the next module, but this allows you to have different values for a setting in the different deployment slots. Let's actually look at creating a connection string, because this will make more sense. If you specify a value for the connection string in your dev deployment slot, you would want to have a different value in the prod deployment slot, because they should be different databases. This checkbox lets you keep the value with the right slot when you swap the code, instead of also having the value swap with the code. When you create a connection string, you can choose the type of database the string applies to. And connection strings are always encrypted at rest. But there's actually another way to have these app setting and connection string values point to values stored in Azure Key Vault if you want to have even more security. I won't go through configuring that here, but just know that it's possible to do by providing access to a key vault using the managed identity of this app service, and then using a certain string format to indicate that the value should come from Key Vault. Let's move on to the General Settings tab. You can change the software framework for running the app from the list available for your underlying operating system. In this case, we're using a Windows App Service. Then you can choose whether the platform should be 32 or 64-bit. 64-bit is only available in the basic and higher pricing tiers. The managed pipeline defaults to integrate it, but if you're migrating a legacy application that ran on an older version of IIS, you might need to set this to classic. Then we can select whether we want to allow FTP access or not, and whether FTP needs to be done over a secure FTPS connection. Below that, you can set the HTTP version. Most modern browsers support HTTP 2.0, which has some optimizations for downloading, and browsers enforce TLS encryption. Below that, you can choose whether you want to enable WebSockets, and you'll need this if you want to use SignalR or Socket.io to have your server code push content to connected clients. The always-on setting is here because when a web app is idle for a while, it gets unloaded to preserve resources. If you're running a web job that's continuous, you'll want to set always on to true. Under that, you can turn off session affinity. When this is on, and your app service plan is scaled out to multiple server instances, the browser gets a cookie that routes the user's session back to the same server instance on subsequent calls. If you're designing your app to be stateless, then you don't need this on, and you can improve performance by turning it off. Then we've got the setting for remote debugging from Visual Studio. When we turn this on, we can connect to the running app in Azure, and this will stay enabled for 48 hours. This works for ASP.NET, ASP.NET Core, and Node.js apps. And at the bottom, you can enable client certificate authentication. You'll need to enable HTTPS for the domain, and Azure will forward the client certificate in the request to your application to validate. On the next tab, because we're on a Windows plan, we can specify the default document for the root URL of a website. This is IIS functionality. Path mapping is another Windows-specific feature. Handler mapping lets you add custom script processors to handle requests for specific file extensions. you'll upload the script processor to the D drive of your app service and point to it from here. You can pass arguments to the custom processor from here too. This gives you a lot of control over responding to requests for certain file types. For example, you could write a custom processor to return RSS formatted XML when the file extension .rss is requested. At the bottom here, you can configure virtual directories and applications. A virtual directory is a path you specify here for users to see in the URL, but it actually maps to a physical location on the D drive of the app service. So you can specify a different name for the virtual directory than for the structure of the physical directory, so users don't see the physical structure of the file system. And again, this would only be available on Windows App Service plans. Next, we're going to look at how some of these tabs present different options for containerized apps. In the last clip, you saw the configuration settings for a web app. Now let's look at how they differ for a containerized app. This is a web app for a custom container, and it was created on a Linux app service plan. The first thing you'll notice under the Settings menu group is that there's an item for container settings. This allows you to change the location of the container image. Let's go back to the configuration menu. We have the same application settings tab, where we can specify app settings and connection strings. The difference here is that these get passed to the container as environment variables in the container. There are some default ones created based on using the quick start image. This is an example of built-in settings names, but of course you can create your own custom settings also. Let's look at the General Settings tab. Here you can provide a startup command to the container. Now, this app service was created for a custom container, so it's assumed that the application stack is included with the container, so you can't change it here. If we had selected a code deployment for a Linux app, we'd have the option to change the framework and version. The rest of the settings on this tab are the same ones you saw in the previous clip for web apps. Let's move on to the Path Mappings tab. Now, this tab has the same name as for Windows web apps, but the functionality is completely different for containers. And remember that if you deploy code and choose Linux as the operating system, you're actually deploying onto pre-configured container images. So for a container, this tab allows you to mount an Azure storage account to be available as a network share in your container. Let's create a new Azure storage mount. I'll give it a name, and let's choose an existing storage account. With the basic configuration option selected, the storage type defaults to Azure Blob. For Linux containers, you can mount either a Blob service container or an Azure file share. But it says here Blob containers are only supported for read access since February 2020. That's because of a problem with the underlying Blob Fuse technology used to map blob storage as network shares. Mapping the blob service isn't available at all for Windows containers. So if you want to use Azure Storage as a network share for your Linux or Windows custom containers, you'll need to use Azure Files for read-write access. Let's change this to Advanced Configuration and choose Files. Now we specify the name of the file share, and the mount path is a folder inside the file share. Something to keep in mind is that the directory you specify as the mount path should be empty, because if it isn't, anything in this directory will get deleted when an external mount is added here. If the directory isn't empty, make sure you do a backup of the files before doing this. So those are some of the different configuration options available when you deploy containers to an app service. Next, let's talk about different options for deploying your app to app services. Let's review the different options for deploying your code to Azure App Service. I won't go into too much detail here because I've got a whole module on deployment in my course on managing Microsoft Azure App Service plans, but let's review the different ways you can deploy your code to App Service. If you're developing in Visual Studio or VS Code, you can deploy directly from the tools. If you've got contributor credentials on the app service, you can connect directly and choose your app service for deployment. If you don't have those credentials, an administrator can download the published profile from the Azure portal and provide it to you. Inside that profile are app-level credentials that will allow Visual Studio to authenticate to the app service and deploy the code. You can deploy from your local Git repository, and the Kudu build server in Azure App Service will compile your code and deploy it to your app service. You can set up continuous deployment to Azure App Service from code repositories like Azure DevOps repos or from Bitbucket and GitHub. You can use GitHub Actions to deploy your web apps, and we saw that a little bit in the previous module when we looked at static web apps. You can also use GitHub Actions to deploy container images. You still need a container registry to store the custom containers, though. For containers, you can also do continuous integration and continuous deployment from Azure Container Registries and Docker Hub. Sometimes there's a separation of responsibilities within an organization, though, whereby developers have to package their code and provide it to an operations team to deploy into the prod environment, for example. For that scenario, there are other deployment options available. You can drop your code in a cloud folder in OneDrive or Dropbox and deploy your code on demand from within the Azure portal. This is called Cloud Sync in the documentation. You can deploy to Azure App Service using FTP with an FTP client. You can generate the credentials for that in the Azure portal, or use the app-level credentials that are embedded in the published profile. You can deploy your app as a deployment zip package file. This actually runs your app from a read-only zip file that's either stored on the file system of the web server, or you can even store the zip file in Azure Storage and point the app service to that file using an application setting. You can secure that file in Azure Storage using a shared access signature, so it's not available to anyone on the internet. And you can also deploy your app using a zip file by either dragging it right into the Kudu console for your app service, or by pushing it to the REST endpoint programmatically. Let's look at using the Kudu interface in the next clip. Now let's create a simple ASP.NET Core web app in Visual Studio and see how we can deploy it to Azure App Service using zip deploy. I'll create a new project and choose ASP.NET Core Web Application from the list of templates. Let's just give this a name, and this doesn't have to match the name of the app service or anything like that. On the next page, let's select a web application with Razor Pages. And notice that authentication is set to no authentication. We could configure this app to integrate directly with Azure Active Directory or other authentication providers, but we're going to let App Service handle that for us in the next clip. So let's just leave the default, which allows anonymous access to the application. I'll click Create, and it'll just take a few seconds to create the app. When the app is created, we've got a functioning web page, and we can run it locally in IIS Express on the host computer. The web app opens in the browser, and you can see in the address bar that it's running on the local computer in the web server that Visual Studio provides. Okay, let's stop debugging. I'll open up Solution Explorer and right-click on the project and choose Publish. First, let's see what happens when I choose Azure. On the next tab, we can narrow down the service to deploy to. I'll choose Azure App Service on Windows. I'm logged into Visual Studio with an account that's an administrator in my Azure subscription, so I have access to all the resource groups. All you need here is the contributor or website contributor role on the app service though, and you'll be able to choose the app service from here. I'll just open up the one with the app service we created. I can see the web app, and if there were deployment slots created, I'd be able to deploy to one of them. But we're not going to publish this way for this example, so let's close this dialog. Instead, I'm going to choose to publish to a folder. So I'll click Start again on the Publish page, and this time choose the Folder option. I'll browse to a folder on my desktop called Publish Files, and open that, and click Finish. Then all I have to do is click Publish. Now I'll navigate to that folder on my hard drive, and select all the files, and use Windows Explorer to compress them into a zip file. And I'll name that file Deployment Files, but you can name it whatever you want. I'll open up the browser again, and I've already got the Azure portal open, and I'm inside the blade for the web app that we created earlier. Over here on the right is the URL to the app. So let's copy that and open a new tab and paste in the URL. We've still just got the default page because we haven't published a web app yet. So now let's open another tab, and I'll paste in the web app URL again. But now let's add SCM between the app name and azurewebsites.net. That opens up the Kudu console for this app service. There's a lot of features available here, but the one we're interested in is under Tools, and it's called Zip Push Deploy. This opens up a view of the files under the www root directory on the app service. So I'll open Windows Explorer again, and I'll drag this file right onto the browser window and release it. Now you can see in the top right corner here, there's a little progress number and a knife that's showing work being done. At the bottom, there's an update of all the activities happening for the deployment. When it's done, we can see that the deployment was successful, and we can also see the deployed files for the web app. Let's go back to the browser tab with our default web app page and hit refresh. And the web app has been successfully deployed. Next, let's look at how we can secure this app with Azure Active Directory authentication. In this demo, we'll set up app service authentication using Azure Active Directory. We'll be securing a web application, so users will get redirected to log into Azure AD once this setting is in place. And then app service authentication will pass headers to the app with user identity information that you can use to do your own authorization within the app. I'm inside the web application, and to configure authentication, you just scroll down to the Settings section of the menu and click Authentication Authorization. First thing you need to do is turn it on. There are 5 providers here that we can enable: Azure AD, Facebook, Google, Twitter, and Microsoft accounts, which are Hotmail and Outlook.com accounts. In other words, user identities that are stored outside the Azure Active Directory tenant for your subscription. At the bottom, there are advanced settings that enable the token store, which is storage for the authentication tokens that are returned by these services. In case your app needs to do anything against one of these services, like post to the user's Facebook page, you can retrieve the token from the store. Allow external redirect URLs has to do with more advanced OAuth 2.0 scenarios. First, we need to decide what action to take when a request is not authenticated. Choosing any of the login options forces a user to log in before they can access the app, but it ties you to a specific provider. If you want the users to log in using one of several providers, like either Azure AD, Facebook, or Twitter, then you choose the first option to allow anonymous requests. You still have to configure the providers you want, and then provide links on the homepage of your app that lets the user choose, and the links would redirect to built-in endpoints used by App Service. That's beyond the scope of this course, but that's one of the situations where you'd use this setting. So let's choose Login with Azure Active Directory, and click to configure it. If we choose the advanced option, we'd have to set up the registration of this application in Azure Active Directory first. We've got a pretty simple authentication scenario here though, so let's choose the Express settings. This will create the app registration for us in Azure AD and make all the necessary connections. We'll leave Create New AD App selected, and we could change the name of the registered app in Azure AD if we wanted to show it as something more friendly, but let's just leave this. I'll click OK and save these authentication settings. Now let's go back to the overview page for the app service and copy the URL for the web app. Now I'll open up a new incognito window, so we don't need to worry about any cached Azure AD settings for my Azure portal login, and I'll paste in the URL. I'll log in with a user that I know doesn't have any permissions in this web app. And the first time I access this application as this user, I need to accept the permission request that the app wants to sign me in and read my profile information from Azure AD. So I'll accept this. And I'm brought into the application. Remember, I didn't have to write any code in my application to set this up. I'd have to write a little code if I wanted to get the user information from the headers, or in the case of ASP.NET, those credentials get passed into a user principal object that you can use in code. In this module, you learned about configuring application settings for web apps and custom containers deployed to Azure App Service. Then you got an overview of the different options for deploying apps to App Service. We created a new app in Visual Studio, and you saw how to publish the app by zipping up the files and dropping them in the Kudu portal for the App Service. And finally, you learned how to authenticate users to the App Service using built-in authentication features. In the next module, you're going to learn about deployment slots, which provide a test and staging area for your app service and an easy way to promote them through the environments to production. In this module, you'll learn about deployment slots in Azure App Service. This feature allows you to run multiple versions of your site, basically setting up different environments, and then easily promote your app through to production. First, I'll provide an overview of deployment slots, what purpose they serve, and how they work. Then, we'll get into the demos. First, configuring the settings of a web app that we want to create a deployment slot for. Then we'll create the deployment slot and clone the application settings from the production site. Next, we'll deploy a new version of the application to the new deployment slot, and then we'll do a swap to production. Along the way, I'll show you how to configure the settings that remain static with each deployment slot, like the values of connection strings for your staging and prod environments, as well as settings that can be swapped. So let's get started with an overview of deployment slots. Deployment slots are a feature of Azure App Service that lets you have multiple versions of your application running within the same app service, so you can use them as different environments, like a staging version of your app for testing and verification, and a production version that your users see. A deployment slot is really a complete app within App Service, with its own application settings, connection strings, and other configuration settings. It has its own place on the file system, and even its own instance of the Kudu portal. In fact, the main app service that gets created when you provision a web app or function app is really a production deployment slot. So every app service has at least one deployment slot. And depending on the app service plan pricing tier, you can create other deployment slots. At the standard pricing tier, you get 5 deployment slots, and at the premium tier, you get up to 20. Each deployment slot will have its own URL, with the same name as the main production app, a dash, and then the name of the deployment slot. You can name deployment slots whatever you want. If we named a slot staging, for example, The URL would be mysite-staging.azurewebsites.net. The power of deployment slots is that you can swap them, so you can deploy a new version of your app to your staging deployment slot, for example, test it out at its URL while your users are still using the production version of the app. Then when you've confirmed that staging is working properly, you can swap it with production and users will start to see the new version of the app. If there are any problems in production, you can just swap it again and your users will get the old version back. Another reason you might use deployment slots is because an app gets restarted after a deployment, and the first request to the site can be slow while the application starts up. Deployment slots give you a way to warm up the site by making requests to it, as well as testing the newly deployed functionality before you promote the site to production. The reason the site is already warmed up when you swap it to production is because swapping doesn't actually copy any files. It just swaps the DNS pointers, so the URL for production points to the deployed app that you moved into the staging slot, and vice versa. If you're not interested in testing out your application before swapping it, and all you want to use deployment slots for is preventing the cold start that could slow down users from accessing your production app, you can enable a feature called Auto Swap. With Auto Swap, you deploy to a deployment slot, let's call it staging again. App Service will warm up the app for you, and then automatically swap the DNS pointers without any intervention on your part. Because you can have multiple deployment slots within an app service, you can configure the target slot for auto swap in the portal. Another feature of deployment slots is called traffic routing. You can actually route a percentage of your production traffic to another deployment slot, so you can test out new features of the site with a limited number of real users before you roll out the features to everyone. This is called testing in production, or A/B testing. Each deployment slot has its own copy of application settings, and you can configure whether or not the values of some of those settings get swapped. When you do a swap of your code between deployment slots, most of the settings get swapped by default. General settings, like the framework versions and the setting to enable WebSockets. Also, the handler mappings and the web jobs are swapped too. App settings and connection strings get swapped as well, but you can configure them to stay stuck with the deployment slot. This makes sense for things like connection strings. You wouldn't want the database connection string for your staging environment swapped into production, because then the production app would be pointing to the staging database after the swap. I'll show you how to configure those settings in the upcoming demo. Settings that don't get swapped include the publishing endpoints and any custom domain names and SSL certificates, which makes sense because your production slot would likely have the custom domain and certificate, so you wouldn't want that being swapped into the staging environment. The scale settings for the app service and web job schedulers are also not swapped. IP restrictions aren't swapped. Diagnostic settings, CORS settings, and VNet integration settings aren't swapped either. It is possible to override this for all these non-swappable settings though, and make them all swappable. You'll need to add an application setting to each deployment slot called Website Override Preserve Default Sticky Slot Settings, and set it to 0 or false. But this is all or nothing. You can't pick and choose settings from this list. So I mentioned that what's happening during a swap is that the DNS pointers are really all that's getting swapped. There's a feature called Swap with Preview that basically pauses the swap before it completes and lets you test your source deployment slot, again, let's call that staging, with the production settings applied to it. So you can verify that your staging site works with the production settings, like the connection string to the production database, essentially testing a new version of prod before your users actually see it. The users are still using the production deployment slot until you complete the swap. Then, if you think everything is okay, you can complete the swap and staging will finish swapping with prod. Or, if there's a problem, you can roll back the changes. I've mentioned that each deployment slot can have its application settings or connection string values remain constant with the slot. So what about updating the actual database when there are schema changes? Well, that's something you have to coordinate yourself, most likely by running scripts on the database to make any schema changes you might need. You need to be aware of timing this, because you could break the production site if the code and database schema don't match. So you could plan for some downtime while the database changes and the deployment slot swapping take place. That's outside the scope of this course, but just remember there's no magic here. You still need to plan when you have dependencies outside the app service. Something else that's important to keep in mind is that the deployment slot is another app running on the same infrastructure as your production site. So if you start directing a lot of traffic to the deployment slot, or doing load testing on the app in the deployment slot, you could impact the production application. So the recommendation from Microsoft is that a test environment should be on its own app service plan, and deployment slots should be leveraged for a staging and production type scenario. So basically, any load testing is done in its own app service plan, and in production, you've got a deployment slot that's just used to verify that the new version of the app is working and warm it up before the swap. I've made some updates to the application that we published in the last module. Remember, this is a .NET Core 3.1 application that I created using the template in Visual Studio. I've added some settings in the appsettings.json file, and we're going to duplicate these settings in the Azure portal for the web app, so we can modify them separately in the different deployment slots. Those settings in the deployment slots will be overriding these values in the app settings file. I've got a setting called environment name, which is just a standard application setting. Then there's a nested setting, because the way you represent this in the portal is a little different. These first two settings are going to be specific to each deployment slot, so the values will stay with the deployment slots and won't get swapped when we promote the app to production. Below those settings are a setting that is going to get swapped, so I've called it non-sticky setting for that reason. It just says where the original value was set. Then I've got a connection string, and we're going to be adding values in the Azure portal for each deployment slot that are slot specific. That is, they'll stick to the slot. This is really important with deployment slots, because you don't want to promote your code from staging to prod and have the prod code pointing to a staging database. Now I've put the source code for this project in the course downloads, as well as a version that you can publish using the zip deploy method, in case you don't have Visual Studio. In startup.cs, the default configuration loads the environment variables. The way configuration works in ASP.NET Core is that the appsettings.json file is loaded, and then the environment variables are loaded. If an environment variable has the same name as an entry in appsettings.json, the value in appsettings.json is overridden by the environment variable. Remember that application settings in App Service are seen as environment variables to the code. Then, on the code behind for the Razor page, I'm just taking the values from the configuration settings and passing them to the page as view data. And in the index.cshtml page, I've added some code to display the values. Let's run this on the local VM and see what it looks like. Okay, so the values are getting picked up from the appsettings.json file that's part of my Visual Studio project, and the app is running in the local development server as localhost. Let's close this tab. And I've got the Azure portal open, and it's open to the app services where we want to create the deployment slot and deploy this application. So there's only one deployment slot really at this point, and that's the production slot, which is always created with an app service. We've already deployed the previous version of the application here. Let's go down to Configuration and open the application settings. And let's set up the settings we want to keep in production and the ones we want to swap with staging. I'll add a new setting and call it environment name, give it a value of prod, and check that this will be a deployment slot setting, meaning that the value will not get overwritten with the value coming from staging when we swap the deployment slots. Now let's add the setting that was nested in my app settings file. The first level was called level 1, and I'll add 2 underscores to indicate that the next value is underneath in the hierarchy. And let's give this a value of prod setting, and also make it a slot setting that will stick to prod. Now let's add a value that will get swapped. It's called non-sticky setting, and I'll give it the value set in prod. I won't check the deployment slot setting checkbox, because again, I want this value to get swapped, so it'll be overwritten with the value coming from staging. Now let's enter a connection string. The connection string I had in my app settings file for local development was called mydbconnection. I've got a value on my clipboard, so I'll just paste that in. And that's going to keep pointing to the database after we swap, because I want to set the connection string value to stay with this slot. Now I'll just save these settings. In the next clip, we're going to create a deployment slot for staging and copy these settings, and then modify the values for that environment. We've updated our application settings for the main application here, which you could call the production deployment slot, but it's really the only deployment slot at this point. So let's create a deployment slot for staging. I'll go to Deployment Slots under the Deployment group and click Add Slot. Let's call it Staging. And remember that depending on the app service plan pricing tier you've chosen, you can have several of these deployment slots for dev, test, UAT, whatever you want. Now you can either have this deployment slot created with a new default configuration, or clone the configuration from another deployment slot. I'm going to clone all the settings from prod, so I don't have to recreate them in staging. The new deployment slot is getting created, and this will essentially be a new site on the same infrastructure within the app service plan, and we'll access that site from within this app service. The deployment slot has been created, and it's been named after the app service with staging appended on the end. Notice you have the ability to route a percentage of production traffic to this slot. This gives you the ability to get feedback on new features from a percentage of users before those features become available to all production users. Let's navigate into this deployment slot. And the deployment slot opens up, and it looks like we're in the main production app, but if you look at the menu at the top, it shows that we're in the deployment slot called staging. So this should make it clear that each deployment slot has its own configuration. We had authentication enabled on the production deployment slot, and we set that up so users had to log in with Azure Active Directory. If I open up authentication for the staging deployment slot, authentication is set to off, and that's because this is one of the settings that doesn't get copied or swapped between slots. Let's open up configuration and look at the application settings. And let's look at the settings we added. I'll change some of these values for the staging deployment slot configuration. The environment name will be staging, and remember, these will override the values in the app settings.config file that gets uploaded when we deploy the app. Then I'll set this tiered setting to staging setting, and these values will stay with the slot. They won't get swapped to production because I've got slot setting checked for both of these. For the non-sticky setting value, I'll change it to set in staging, and this value will get swapped to production because it's not configured as a deployment slot setting. Now I'll just update the value of the connection string that was copied from prod. I'm changing the initial catalog or the database name to staging for this connection string. So from our staging deployment slot, the code would always connect to a different database than the code running in the production deployment slot. I'm not actually deploying any databases here. This is just an example of how connection strings work. Now let's save these settings. And let's go back to Visual Studio and publish the app to the staging deployment slot. I'll create a new publish profile and select an existing Azure App Service. I'll click Next with these default settings for Azure and Windows App Service. Because I'm a subscription admin, I can see all the resource groups with app services. So let's expand the resource group we created the app service in, and the web app, and expand the deployment slots folder, and select the staging deployment slot we just created, and click Finish. That's all there is to deploying from Visual Studio. The browser opens up to the version of the app running in the staging deployment slot, as you can see from the URL in the address bar. The application settings we configured in the Azure portal are overriding the ones in the appsettings.json file, and the code is picking those up. Everything here shows as staging, as opposed to dev, which it was in the app settings file. In the next clip, let's do a swap of the staging and production deployment slots. The browser is open to the app running in the staging deployment slot, so let's copy this URL and I'll open a new tab. I'll paste in the URL and take out the staging part. And because we enabled Azure Active Directory authentication in the last module, and it's the first time I've accessed the production site with my logged in administrator credentials, I'm being asked to grant permissions to the app, so I'll accept that. And I'm brought to the last version of the app that we deployed to production, because this was our only deployment slot at the time. Let's switch back to the Azure portal, and let's back out of the staging deployment slot and back to the main app service, which is the production slot, really. We could initiate the swap from inside the staging deployment slot, but I'll show you here that you can go to the overview of the app service and initiate a swap from the toolbar at the top. There are two options. We can either swap with preview or just do a normal swap. We talked about swap with preview in the overview earlier in the module. Let's do a normal swap. I'll keep staging as the source and production as the destination, but if I had more deployment slots configured, I could choose them here. App Service provides a summary of the changes that will happen with the swap. As expected, it says the non-sticky setting in prod will get overwritten by the value that was set in staging, which is exactly what we wanted when we didn't check the deployment slot setting checkbox. So I'll click Swap to start the process. It takes about a minute for the swap to complete, so I'll pause the recording here. And the deployment slots have been swapped successfully. So let's go back to the tab where the production site is running, and I'll refresh the page. And the new version of the app is shown, and the values we set in the production deployment slot have been picked up. The environment name is prod. The setting that was in a hierarchy in the app settings file is set to prod setting, The connection string is the one that was set in the production deployment slot, and this application setting that we didn't mark as a slot setting got swapped from the staging slot into the production slot. It says it was set in staging. Now let's open a new browser window so we don't have any logged in credentials hanging around, and I'll paste in the URL to the staging deployment slot, and the version of the site that was previously in production shows up. So that's how to configure deployment slots and do a swap using the Azure portal. Remember, you could also set up auto swap, or you could initiate the swap using PowerShell or the Azure CLI. In this module, you learned about deployment slots in Azure App Service. First, you got an overview of the reasons to use deployment slots, the features available, and how they work. Then we configured the settings of a web app to prepare for creating a staging deployment slot. We created the deployment slot and updated the settings for it, and then deployed a new version of the app to the staging deployment slot. And then we swapped the staging slot with the production slot so our users would get a new version of the application. In the next module, you'll see how to manage custom domains for your app service. If you're publishing applications to clients, you probably don't want to give them a URL with azurewebsites.net on the end of it. So in this module, you'll learn all about configuring custom domains for your app services. First, I'll explain how custom domains work in Azure App Service. You can configure an existing domain name in an external DNS provider, or you can purchase one from within App Service and have it managed by Azure DNS. I'll explain the different approaches and give a quick review of the different types of DNS records that you'll need to configure if you go the external route. Then we'll map a root domain to an app service using an external provider. Because it's a root domain, specifically it'll be exampleorg.com, you'll need to create an A record in DNS to map to the IP address of the site. Once that's done, we'll create a domain alias in the external DNS so that www.exampleorg.com also resolves to the web app. And then we'll also create a subdomain called test.exampleorg.com that will point to the staging deployment slot that we created in the last module. Then I'll show you how to purchase a custom domain from within App Service, and Azure will manage that domain using Azure DNS, including creating all the relevant records. It makes things really simple. I'll also show you the records that were created in Azure DNS in case you ever need to manage them. So let's get started with an overview of custom domains in Azure App Service. Azure App Service allows you to use a custom domain with any of the app services you create. That way you don't have to keep using the URL that gets created by default, which is your domain name .azurewebsites.net. You can either purchase your custom domain name through a third-party registrar, or purchase it directly in Azure, in which case you're actually purchasing the domain through GoDaddy, but it all gets handled for you within the Azure portal. In order to use custom domains with your app service, you need to be on a paid tier. The free tier doesn't support custom domains, but any of the other tiers, like the shared tier, basic tier, standard tier, or the premium tiers, all support custom domains. If you created your app service in the free tier, you can always scale it up to one of the paid tiers to get access to this and other features. Let's talk first about custom domains that you purchase outside of Azure and that you want to use with your Azure App Service. A domain registrar is a company who can provide internet domain names. They verify if the internet domain you want to use is available and allow you to purchase it. And once the domain name is registered, you're the legal owner for the domain name. Your domain registrar most likely does DNS hosting for you and has tools available to allow you to point your domain at a web application hosted somewhere on the internet. That means either pointing your domain name to an IP address somewhere that's hosting your site, or to an existing domain name, so your domain name essentially becomes an alias to the existing one. Either way, your domain registrar is responsible for telling all the other DNS servers on the internet how to find your hosted site, so anyone typing in your domain address will be directed there. You can also create subdomains off of your root domain and point those to different websites, or to the same website if you wanted. In all these cases, your DNS registrar is handling the management of your domain. In the upcoming demo, I'll configure an outside DNS provider to point to my Azure App Service website. There's also a service within Azure called Azure DNS that you can delegate that DNS management to if you like. Azure DNS isn't a domain registrar. It's just for hosting your DNS domain and managing DNS records. If you've already purchased a domain from a domain registrar and you want to manage it with Azure DNS, You would create name server records with your DNS registrar to point to the Azure DNS name servers. Then you can manage the domain and any subdomains from within the Azure portal, using the same credentials, tools, and billing as your other Azure services. You also get role-based access control and activity logs to track who made changes to the configuration. You can also purchase a custom domain from within Azure App Service. When you do this, Azure DNS automatically creates a new DNS zone for your domain and starts managing it. You'll see that in the upcoming demo too. Now let's talk a little bit about IP addresses and DNS records. App Service is a multi-tenant service where network infrastructure is shared. It's only when you move to the isolated pricing tier, or App Service environments, that you get dedicated networking. With ASE, apps get static dedicated IP addresses for inbound and outbound communication. But on the other pricing tiers, like the standard pricing tier that we've been creating the examples in so far, the inbound and outbound IP addresses of an app can be different, and they can even change. When you create an Azure App Service plan, all the apps and deployment slots in the App Service plan share the same IP address by default. That inbound IP address can change if you delete all the app services and recreate them in a different resource group, for example. But if you really want a static IP address for your App Service app, you can get a static inbound IP by configuring an IP-based SSL binding. In an IP-based SSL binding, the certificate is bound to the IP address, so App Service provisions a static IP address to make that work. We'll be binding SSL certificates in the next module. The IP address can still change if you delete the SSL binding, like during a certificate renewal if you don't attach the new certificate before deleting the old one. There's also a newer feature of App Service called Private Endpoints that allows your App Service to have a private IP address in your own Azure Virtual Network. This eliminates exposing your App Service to the internet and makes it only available from on-premises networks that connect to the VNet using a VPN or ExpressRoute connection. If you need to whitelist the outbound IP addresses of your App Service, like for a firewall to another service, you can find those IP addresses within the Azure portal or by using PowerShell or the Azure CLI. There are several outbound addresses for your App Service, so you'd need to whitelist all of them, and they can change if you scale your App Service between lower pricing tiers and the Premium V2 tier. In the next demo, I'll be configuring a domain registrar to point an existing domain name to Azure App Service. Before we get into that though, there are a few types of DNS records you need to be aware of. Your domain name without any prefix is called the root domain, or the apex. So exampleorg.com is a root domain. A subdomain is created by prepending a name before the root domain. So admin.exampleorg.com is a subdomain. So is www.exampleorg.com, which might surprise you since the www part is used so often. DNS servers, or domain name system servers throughout the internet, have A records and CNAME records. There are other types too, but those are the primary ones for resolving website addresses. A records, or address records, point a domain name directly to an IP address, whereas CNAME records are aliases that point one subdomain to another domain or subdomain. CNAME stands for Canonical Name Record. TXT records are a flexible type of record that stores strings and can be used for a variety of purposes. Because your app service is created using a default URL suffixed with azurewebsites.net, you can just create a CNAME record with your registrar to point to the Azure URL. The only problem comes in when you want to point a root domain, like exampleorg.com, to the website. You're not supposed to use CNAME records for the root domain because it can conflict with other record types for reasons that have to do with the original DNS standards. In the next demo, I'll show you how to map an A record to an Azure App Service using an external DNS provider, and also how to use CNAME records for the subdomains. In this demo, we're going to configure my external DNS provider to point a root domain, exampleorg.com, to my App Service web app. Before we do that though, we need to make a change to the deployed code. The ASP.NET Core project we deployed has some code that forces strict transport security. Because we won't have a certificate attached to this custom domain, we'll get errors in the browser. If you've got an app service that you just created and it still has the default page, you can just skip this next part. In the Visual Studio project, open up startup.cs, and in the configure method, I've commented out 2 lines. app.usehsts, which enforces strict transport security through the use of a response header, and app.usehttps redirection. Now create a new publish profile, or you could publish the files like before using zip deploy, and I've put those published files in the course downloads. But let's create a new publish profile. I'll connect to the app service, and we'll publish to the production slot. I'll just publish this, and the browser opens to the default azurewebsites.net address. Let's go back to the Azure portal and down to custom domains. We're going to create a record in DNS that points to the root of the website. We could create a CNAME record to the azurewebsites.net address, but let's see how to create an A record to the IP address first. I'll copy the IP address, and let's go to the administration page of my DNS provider. I use EasyDNS, but any DNS manager will have similar steps. You're creating the same records, just the screens will look different. So I'm in the domain administration for exampleorg.com. I'll go to DNS settings and click on the link for A records. The root domain is also known as the apex, so you can use this @ symbol to represent the root of the domain. Then I'll paste in the IP address of the app service. Now I'll click Next and confirm, and then Done. Your provider might not have as many steps, but you get the idea. Now because we used an A record, Azure needs a TXT record to verify that I'm the owner of the domain. This is only used during configuration in Azure, and you can delete it after if you want. Now let's create that TXT record. Azure looks for a specific name and value for this record. The name is ASUID. Whatever your root domain is, and the value is provided in the Azure portal. Let's go back and copy that. It's called the Custom Domain Verification ID, and it's kind of like a shared secret, so no one else can point their custom domain to your app service. Let's paste that in, click Next, confirm, and Done. We're done here in the external DNS provider, so let's go back to the Azure portal and configure the app service now. I'm already within the Custom Domain tab in the web app, so I'll click on Add Custom Domain, and I'll type in the root domain that we just configured the A record for, exampleorg.com. Then I'll click Validate. You can choose the record type from this dropdown, but because it's a root domain, it defaults to an A record. If we scroll down to the bottom, Azure App Service has reached out to the external DNS provider because the DNS has already been published to the internet, and it's verified that I'm the domain owner because I created that TXT record with my DNS provider. Let's go back to the overview page, and you can see the default URL is now the custom domain, and it's using HTTP. Let's click Browse. The page starts to open, but we get redirected to log in, and we can't do that on an HTTP endpoint when authentication is enabled. Authentication requires HTTPS be configured. So let's go back in the portal and turn off authentication for now. I'll save these changes. And let's go back and try to browse to the page again. This time it opens up. It says it's not secure though, and that's because there's no certificate attached to this custom domain. I'll show you how to attach a certificate in the next module. So in the next clip, let's add some CNAME records in order to use the www subdomain for this web app. And we'll add a subdomain for the staging deployment slot too. In this demo, we're going to create two subdomains using CNAME records in my external DNS. One subdomain for the production website, which will be a www subdomain on exampleorg.com. And we'll also create a subdomain for the staging deployment slot, which will be test.exampleorg.com. I'm inside the main production web app here, so let's get the URL for the deployment slot, because we'll need that for the CNAME record. I'll click on the staging deployment slot and open it up, and I'll copy the hostname that was automatically created for this deployment slot. Now I'll open up the tab where I'm logged into my external domain manager, where we can create the CNAME records for the subdomains. I'll open up CNAME records, and there aren't any created yet, so let's edit this. And the first thing I'll create will be test.exampleorg.com, and we'll point that to the URL for the staging deployment slot. Notice the trailing period at the end. The period indicates that this is an absolute URL, or a fully qualified domain name, that shouldn't be suffixed with anything else when being resolved. This has to do with the DNS specification, and it's required in this interface when pointing to a host at a domain other than the current exampleorg.com domain. Then let's create a www subdomain for the production web app. So essentially this is an alias if someone types www in front of the domain name, which is pretty common. and we'll have this resolved to the root domain name. Then I'll actually do the same for the test domain. I'll create www.test.exampleorg.com to point to the domain without the triple W. We could actually use the URL that goes directly to the deployment slot, but this works too. Now I'll click Next, and I get a warning that test.exampleorg.com isn't a valid server, but that's just because it hasn't been created yet. So I'll confirm this, click Done. Now we also need to create TXT records for Azure to verify these subdomains. So let's do that while we're in the portal here. I'll copy this domain verification ID that we used in the previous clip. Remember, this came from the Azure portal. And let's create new entries with the ASUID prefix and the subdomains that we want to verify. There's the www for the root domain, then the test subdomain, and www.test. And they all use the same verification ID. Okay, let's confirm these changes. And now let's go back to the Azure portal. We're still in the staging slot here, and let's add the subdomain for the staging slot. I'll click on Add Custom Domain, and in the blade that opens, I'll type test.exampleorg.com and click Validate. And once it's validated, we can click Add Hostname. Now let's add another hostname, and type in www.test.exampleorg.com, and let's validate this one, and add this hostname also. Okay, let's back out of the deployment slot and go back to the main production slot. I'll scroll down to Custom Domains. Here we'll add the W subdomain and validate it, and add the hostname. Okay, that's it for configuration. Now we'll open up a browser, and the page is already open to exampleorg.com. So let's navigate to the deployment slot first. I'll type in test.exampleorg.com, and then I'm brought into the web app running in the staging deployment slot. Now I'll add the www, and this resolves too. Now let's remove the test part and go to the subdomain of the production deployment slot, which is www.exampleorg.com. And we're brought into the production app. So that's configuring subdomains using an outside DNS provider. Next, you'll see how to purchase a custom domain from within the Azure portal and manage it using Azure DNS. Now let's purchase a custom domain for another one of the app services in the app service plan. I've created another app service and used the existing app service plan, so it's listed here. Let's navigate into it. Let's copy the default URL and open up a new browser tab and paste in the address. So we've got the default page that gets created by Azure. Now let's go back to the portal and let's create a new resource. You need to create an app service domain in order to purchase one. You used to be able to purchase a domain right from within an app service, but now you have to create this resource first and attach it to the app service. I'll create this in the same resource group just to keep things together. And this is where we search for the domain. It says this domain is available, so no one else on the internet has purchased this particular domain. Now you need to enter your contact information. This can be visible on the internet, or you can choose to keep it private, and I'll show you that shortly. I'll just speed up the entering of this, and let's move on to the next tab. This is where you can disable auto-renew if you want. One of the great things about app service domains is that they just get billed on your Azure invoice, so there's no separate billing, and Azure will automatically renew them each year. At the bottom here is where you can manage privacy protection, which keeps your contact information out of the public Whois database on the internet. Some domain providers charge extra for this service, but it's included with app service domains. Let's skip the tags screen and go to Review and Create. Let's create this app service domain. It'll take a few minutes to do this. It's registering the domain with GoDaddy, which is the domain name registrar that Azure uses. It's also creating entries in Azure DNS. So the steps you saw me do manually in my third-party domain registrar are taken care of for you during this process. This will take a few minutes, so I'll pause the recording. And when everything is created, we can navigate to the app service domain. From here you can do things like manage auto-renewal of the domain. Now let's go to App Services and open up the app service I created for this demo. If we go down to Custom Domains, at the bottom are the available app service domains. You can click on this, but it doesn't attach it to your app service. It just brings you to the resource itself, the app service domain. So let's back out of here. And in the app service again, let's click Add Custom Domain. I'll enter the name of the app service domain I purchased and click Validate. I want to make this a CNAME record this time, and I'll click Add Custom Domain. Now let's add another custom domain, and let's add the subdomain www, and we'll make that a CNAME record also. Now let's open another browser tab, and let's navigate to http://anotherorg.com. That brings us to the default page in App Service. Now one more thing I want to show you. If we navigate to the App Service domain again, up at the top is this link to Manage DNS Records. This brings you into Azure DNS, where you can see the records that were created by Azure. If you need these for any reason, or you need to change them, you can do that from here. You can also find out things like the name servers that Azure uses for DNS. So that's how to purchase and attach an App Service domain to your Azure App Service. In this module, you learned how to configure custom domain names for Azure App Services. First, we had a review of how App Service handles IP addresses, as well as the different options available for configuring custom domains. Then we configured a root domain in an external DNS provider to point to a web app in App Service. Then we configured subdomains using CNAME records in the same external DNS. Next, we purchased a custom domain right from within Azure App Service, and you saw how easy it was not only to purchase the domain, but also have it configured and managed by Azure DNS. In the next module, we'll add SSL to the custom domains we configured to enable encryption of traffic between the users and the applications. Now let's talk about binding an SSL certificate to your custom domains in App Service. When you create an Azure App Service, you get a default URL, which is your website name.azurewebsites.net. Encryption is automatically enabled on that endpoint because Azure owns the domain azurewebsites.net, and there's a wildcard certificate that covers your subdomain at no extra cost. But when you want to use your own custom domain, as we saw in the last module, you also need your own SSL certificate if you want to encrypt the traffic between your site and the people that use it. Now, something to keep in mind about an SSL certificate is that the domain name or subdomain that the client is accessing must match the subject name in the certificate, or you need the domain name included in the subject alternative name, or SAN, of the certificate. When you purchase a certificate for a root domain, you often get the www subdomain added in the subject alternative name. But if you don't, then you can't use that certificate with that subdomain. The alternative is to purchase a wildcard certificate, which allows it to be used for all subdomains of the root domain. Wildcard certificates are really flexible, but they're also significantly more expensive. There are 4 ways to use SSL certificates with a custom domain on your app service. You can import your own certificate as a PFX file and bind it to the domains and subdomains of your app service. In order to use an externally purchased certificate in Azure App Service, the certificate needs to meet 4 requirements. It needs to be signed by a trusted certificate authority, so you can't use a self-signed certificate. It needs to be purchased from a trusted authority. This is because browsers come pre-configured with the root certificates for these authorities, so any certificates issued based on those root certificates will automatically be trusted. The certificate needs to be exported as a password-protected PFX file. Usually the certificate authority will send you the certificate as plain text, so you'll most likely need to do this step yourself. The certificate must contain the private key with a key length of at least 2048 bits. The certificate must contain all intermediate certificates in the certificate chain. You can get the intermediate certificates from the certificate authority, but then you'll have to combine them yourself before uploading the certificate to App Service. You can do this using a tool like OpenSSL or using Internet Information Services Manager. I'll show you how to do that in the upcoming demo. You can upload the certificate directly into your Azure App Service and use it there. Or you can also upload the private key into an Azure Key Vault instance in your subscription. Then you can manage all your certificates centrally in Key Vault. If you update your certificate in Key Vault with a new certificate, App Service automatically syncs your certificate within 48 hours. If purchasing a certificate and importing it seems like a lot of work, Azure offers a couple of alternatives to make things much easier. The first is called App Service Managed Certificates. These are fully functional TLS SSL certificates that are managed by App Service and renewed automatically. And they're actually free to use for dev and for production. There are some limitations though. App Service Managed Certificates don't support wildcard certificates, and they also don't support root domains or A records, so you can only generate them for subdomains like www. They're not exportable either. They're managed by Azure. Even though there are limitations, it's a simple and free way to secure your custom domain. App Service Managed Certificates are available on the basic pricing tier and above. If you need more functionality, there are App Service Certificates. These are certificates you purchase through Azure, and Microsoft has partnered with GoDaddy as the certificate authority. These certificates support root or apex domains, like exampleorg.com, without the www. So you can purchase a certificate for your domain or subdomain and get the corresponding www subdomain also. Or you can purchase a wildcard certificate for all subdomains. The certificate gets stored in an Azure Key Vault instance, and Azure handles renewing and rekeying the certificate. When you bind a certificate, whether you've purchased it outside Azure or you're using an App Service certificate created within Azure, you have two options when it comes to binding it to your domain and subdomains. You can choose IP-based SSL or SNI-based SSL. IP-based SSL is the traditional type of binding, whereby one SSL certificate is used to secure a dedicated public IP address and port combination. If you've got multiple domains, you secure them using the same SSL certificate. Because IP-based SSL requires that the certificate is bound to the IP address, and by default, all your app services share the same IP address, App Service will assign a new dedicated static IP to your app service when you choose IP-based SSL. I'll be using this approach in the upcoming demo. The other option is SNI-based SSL, in which multiple SSL certificates can be used to secure multiple domains on the same IP address and port number. SNI stands for Server Name Indication, and it requires the client, like a browser for example, to tell the server what hostname it's attempting to access. This lets the server present multiple certificates on the same IP address and port number, so multiple websites can be hosted on the IP address without having to use the same certificate. Because the process involves the browser sending certain information in the initial request, it requires a modern browser with SNI support. The last feature of SSL settings in App Service that I'll mention is the ability to upload public certificates, or CER files. If your application needs to access another service that requires a public key, for example, you can store the certificate in App Service and reference it from your code. Just another way for you to separate your code and certificates for easier maintenance. In this module, we've talked about the different ways to secure your custom domains with a certificate. Next, I'll show you how to purchase a certificate from a third-party certificate authority, and then we'll upload that certificate to App Service. After that, we'll re-enable authentication on the App Service, and I'll show you the configuration you'll need to do in Azure Active Directory. Then you'll see App Service Managed Certificates, which let you bind a free SSL certificate to your custom domain in App Service. Now let's purchase a certificate we can upload to Azure. Now let's purchase a certificate from a trusted third-party certificate authority. This isn't anything specific to Azure. It will just prepare us to upload the certificate in the next clip. If you already know how to do this, or you already have a certificate, you can skip ahead. We need to generate a certificate request with our information. You can do that from the command line by installing OpenSSL, or if you're on Windows, you can just use IIS Manager. I'm on a Windows 10 VM, and if I search for programs and open up Programs and Features, you can install IIS Manager by turning on Windows Features. I've already installed the IIS Manager console under Internet Information Services Web Management Tools. Let's close out of all this and open up IIS Manager. I'll expand this and open Server Certificates. From the Actions menu on the right, I'll create a certificate request. We have to fill in some information here that's needed by the certificate authority. The custom domain that I want to create the certificate for is exampleorg.com. The certificate authority will automatically add the www subdomain as a subject alternative name when the certificate is issued. That's pretty common, but whatever issuer you use, make sure they do that. Otherwise, you'll get an error when users browse to the site using the www subdomain. Next, I'll fill in this other company and location information and click Next. I'll leave the default cryptographic service provider, but we need to change the bit length to 2048 to use this certificate with App Service. Now let's save this to the desktop and give it a name. It doesn't matter what the name is, and technically we're generating a CSR file, but we'll actually be copying the contents of the file, so you could just save this as a text file. Okay, let's finish this. The file has been generated and saved to the desktop, so let's navigate there. And let's open this with Notepad. We need to copy the contents here, because I'm going to use a browser-based request form to submit it. Make sure you include all the text. I'll highlight this and copy it. Now you can purchase a certificate from many different providers on the internet, and certificates have different features, but the process is pretty much all the same. I can do this right from within my DNS provider, so I'll go to the page to purchase certificates. I have a few already, but let's purchase a new one. I'll select the domain I want to purchase the certificate for, which is exampleorg.com. I want to create the certificate for the root domain, and as I mentioned, the www subdomain will get added automatically as a subject alternative name. Make sure the certificate authority that you use will do the same. I'll just choose the cheapest option. I don't need a wildcard cert or a cert that's organization validated. Because I'm logged in, I can use my member information on this site. And I need to choose an email address to send the approval request to. That will be the next step after the request is submitted, for the webmaster of this domain to approve the request. That prevents someone else from generating a certificate for your custom domain. At the bottom, I'll paste in the certificate request that was output from IIS Manager, and click Next. Now I'll review the information and click Next again. Now I have to pay. My DNS provider allows me to pay for this using PayPal. I won't go through that, so let's skip ahead. I've paid for and submitted the certificate request. Now I need to wait for the approval email. Let's jump ahead, and I've received the approval email from the certificate authority, so I'll click on this link. And on the page that opens, I just need to click Approve. Now I have to wait for an email with the information for downloading the new certificate. It took about an hour, but here's the email from DigiCert, and it says I can download the certificate from this link. On the page that opens, I'll choose the P7B bundle with the CER extension. That way the intermediate and root certificate are bundled up with the certificate for exampleorg.com. Otherwise, I'd need to put them together myself before completing the request in IIS Manager. Now the CER file is downloaded, so let's open up IIS Manager again. And I'm still in the Server Certificates section, so let's click Complete Certificate Request. The private key was generated when we created the request, and it's stored on this VM. You can export it from the Certificate Manager for the local machine if you need to, but if you're using the same computer, you don't need to worry about that. Let's select the file we just downloaded. We'll give it a friendly name, and we'll import the certificate to the personal store. And now we have a completed certificate on this computer. Next, we need to export it as a PFX file with the private key included, so we can upload that to Azure. Let's open up the certificate store for the local machine, and you can find this from the search box. And there's the exampleorg.com certificate, so let's double-click on it. That opens up the General tab, where you can see it was issued by Rapid SSL. On the Details tab, I'll scroll down to Subject Alternative Name, and the www subdomain is listed here. The certification path shows that the intermediate and root certificates are chained here, so everything is valid. Now let's right-click on the certificate, go to All Tasks, and export this certificate. I'll click Next. We do want to export the private key, because Azure requires that. And let's include the extended properties. Now we need to add a password. Remember to write this down, because you'll need it when you upload the certificate to Azure. We need to use the DDES encryption option for Azure, so I'll leave that. Now let's select a location. I'll put this on the desktop, and I'll call it exampleorg cert, and it will get generated with the PFX file extension. Let's finish this process. It says the export was successful, so let's close this and navigate to the desktop. And there's the PFX file. We could upload this directly to an Azure App Service, or upload it to Azure Key Vault and link it to the App Service. But let's upload directly to the App Service in the next clip. Now that we have a certificate for our custom domain, let's see how to upload and bind it in App Service. I've got an App Service open to the Overview page, and you can see the custom domain is set to exampleorg.com. If I scroll down to TLS SSL settings, there are no certificates available here. Let's go to the Private Key Certificates tab and click Upload Certificate. I need to select the PFX certificate file that we exported in the previous clip. It's on my desktop. And now I need that password that I used when exporting the certificate. Let's upload the certificate. Azure validates the certificate, and now it's available in my list of private key certificates. And it's showing as healthy. All we can do from here is delete the certificate. Next, we need to bind it to the custom domain for this app service. Let's go to Custom Domains and scroll down to the domains we added in the previous module. I'll click Add Binding for this first one. I'll choose the certificate. There's only one in this list, and now I need to choose between IP-based SSL and SNI SSL. If I choose IP-based SSL, we'll get a new IP address for this app service, and we'll have to go back to my external DNS provider and remap the root domain to that IP. So let's choose SNI SSL. That keeps the same IP address. Now I'll click Add Binding. The portal says that the custom domain is secure. Let's do the same thing for the www subdomain. I can choose the same certificate because when it was issued by the certificate authority, the www subdomain was automatically added as a subject alternative name in the certificate. Most certificate authorities will assume you want that. Let's select SNI-based SSL again. Okay, now both custom domains are secured. Let's go up to the overview page and let's browse to the app. We're no longer getting the warning, and we have the lock icon indicating that this is a secured site on an HTTPS endpoint. Let's try the www subdomain. That works too. Next, let's re-enable authentication on this app service now that we have our custom domain secured. Now that we have a custom domain for the web app and an SSL certificate bound to the endpoints, we can re-enable authentication to Azure AD. If we were configuring it for the first time, like back in the earlier module, this would be straightforward. You could just follow the same steps. But since it's already configured with the old azurewebsites.net endpoint, we need to do a little advanced configuration. First thing I'll do is pin this app service to the dashboard, so it'll be easier to find, because we're going to be going to another Azure service in a second. Then I'll copy the new URL, which is https://exampleorg.com. Now let's navigate to Azure Active Directory from the menu. This is where you can create app registrations in the advanced mode. We used express settings from within the app service, but if I navigate down to app registrations on the menu, here's the app registration that was created for us by App Service. We need to change a few values in here. Let's start on the Branding tab. We need to change the homepage URL to our custom domain. Let's save this and go down to Expose an API. Let's change the application ID URI to our custom domain also. And now in authentication, we need to change the domain part of this path to the custom domain and leave the path after the domain, which is a built-in path used by App Service. Now let's copy this and paste in a copy and add the www subdomain also. Let's save this, and that's all we need to do in Azure AD, but we still need to do some configuration within the app service. So I'll go to the dashboard and open up the web app that I pinned to the dashboard. Now I'll scroll down to Authentication Authorization, and let's enable authentication again and go into the advanced settings. Most of this can stay the same. It's just the allowed token audiences at the bottom that need to change. These have to match the reply URLs we configured in Azure AD, so I'll just paste this in. It's the custom domain for the app service, appended with .auth, login, AAD, callback. And I'll copy this and add the www subdomain also. I'll click OK to this. I have to change the action to take when the request is not authenticated. We want that to be set to force the user to log in with Azure Active Directory. And now I can save these changes. Now, let's open up a new browser window and navigate to www.exampleorg.com. Because authentication is enabled, I'm redirected to the login page for Azure AD. I'll enter the credentials of this user who's in my Azure Active Directory, and I get authenticated to the app service on the HTTPS endpoint. So that's how to configure your existing authentication settings after you've added a custom domain and SSL certificate. Okay, now let's create a certificate using the free App Service Managed Certificate. This is currently in preview. Remember, we can only use this on subdomains. It won't work on root domains, and you can't create wildcard certs, but you can with the paid App Service Certificate approach. So let's do this on the subdomain we used for the staging deployment slot. That's under the Deployment Slots menu on the App Service here. I'll open up this deployment slot, and let's browse to the deployed app. We get a warning in the address bar that this URL is not secure, and of course that's because we don't have a certificate bound to this custom domain. So let's do that. I'll close out of here, and let's scroll down to TLS SSL settings. You can see there aren't any certificates added yet. Before we add one, let's look at the custom domains again. There are 2 domains I added in the last module. Let's create a certificate for the test.exampleorg.com subdomain. I'll go back to TLS SSL settings and click on Private Key Certificates. This time, let's choose the option to create App Service Managed Certificate. We can select either of the custom domains that are attached to this App Service deployment slot, so let's choose the test.exampleorg.com domain. It says the host name is eligible for certificate creation. I'll click Create to finish this part. At the bottom, we've got the new certificate, and the certificate we uploaded for the production deployment slot, or the main app service, is also showing there. Now we need to bind this certificate to the custom domain. So let's go back to Custom Domains and click on Add Binding. Now we choose the private certificate thumbprint. And let's use the SNI-based SSL, so we don't have to remap any IP settings in external DNS. Okay, the binding has been added. Now let's try and add another certificate for this other custom domain, the www one. I'll go to Private Certificates and add another managed certificate. It says the host name is eligible, so let's click Create. And we get an error. It doesn't give any further information, and the link just goes to the documentation for App Service Managed Certificates. It looks like you can only create one certificate per deployment slot, at least at the time of filming. And we could remove this custom domain that we can't attach a certificate to, but let's leave it and go back to the overview. And let's browse to the deployed site. The browser opens up to https test.exampleorg.com, and we're no longer getting the certificate error. Let's try the www subdomain. And we still get the certificate error at the subdomain level. App Service Managed Certificates are a new feature that lets you generate a free certificate managed by Azure. You can't export the certificate or use it for a root domain, but it's managed by Azure and automatically renewed every 6 months. So it's a great, no-cost, no-maintenance option for simple requirements. In this course, you learned about Azure App Service. First, we examined the different types of apps you can host in App Service, like web apps, containers, and function apps, as well as static web apps. Then you saw how to configure those apps in the Azure portal, and we deployed a web app and configured authentication to Azure AD. Next, you learned all about using deployment slots to host pre-production versions of your application on the same app service. Then you saw how to configure custom domains, including purchasing a custom domain in Azure. In this module, you learned about the different options for securing your custom domains with an SSL certificate. First, we purchased a certificate from a trusted third party and uploaded it to App Service. Then we re-enabled authentication on that app service. And finally, I showed you App Service Managed Certificates, which is a way to secure your custom domains for free with a certificate managed by Azure. So that's the course. I hope you enjoyed it, and thank you for watching. If you have any questions, please feel free to ask in the discussion section, or just let me know what you thought of the course. My name is Neil Morrissey, and I hope you'll join me for future courses here on Pluralsight.